you only need to check the first and last input and output values to determine if the function is linear. Is he correct? Explain. He is incorrect. Sometimes the first and the last values are going to have the same rate, but the points in the middle may be different. So we're going to explain this by using a table. I have created a table of values where x are my inputs and y's are my outputs. If we check the first ones, we can see here that the difference is 3, and on this side the difference is 2, which would give us a slope of 3 over 2. And in this one, from 15 to 18 is also 3, and from 8 to 10 is 2. So those ones are the same. But if you look at this one right here, from 6 to 10 is a change of 4, and from 4 to 6 is a change of 2. So those are not the same. And then on this one, from 10 to 15 is a change of 5, and from 6 to 8 is a change of 2. So you can see that the rates are not consistent throughout the whole table, even though the first and the last ones are the same. So he is incorrect. You must check that the rate is constant at all input and output pairs. Number 5, is the following a graph of a linear function, and how would you determine if it is a linear function? To determine if this is linear, we want to make sure that the rates between all of our points are the same. So for this one, to move between this point here and the origin, we are going to go up 1 and right 3, which would be a slope of 1/3. Then between that point and the next, we also go up 1 and over 3. So far they are the same. And then for these two, it is also up 1 and over 3. So how would we determine if it's linear? Check the rate, also known as the slope, between the points. To make sure they are the same. And this problem they are, so we will say this is the graph of a linear function.